Okay, this is a video on how to evaluate integrals. So first of all, just some basic rules about the way integrals work. As you can see here in front of you, if you integrate it from a to b, if you turn around and integrate it from b to a, you're just going to get a same value, only opposite. So just to give you a picture of what that looks like, right? If this is right here is a, that right there is b. What we're saying is if you're integrating, if you have your a is your lower limit and b is your upper limit, you can switch them, and all it's going to do is it's going to give you the same value, only with a negative. It's going to give you the exact opposite. So if I'm integrating this way, I'll get a positive value. If I'm integrating that way, I'll get the same value, only negative. Okay, so that's a good thing to know. Also, in this case, let's put a little c in between there. So what this second rule is telling me, that if I integrate from a to c, and then I integrate, so that's this part, right? Then I integrate from c to b, that would be that part. I could have just integrated from a to b, and that would have been the same as adding those two together, as long as c is between a and b. And f of x is continuous on the interval from a to b. So that's interesting. Here's another one. If you're multiplying some function by 2 inside the integral, you could just take the 2 out and integrate what's left and then multiply by 2 and you're done. So you remember that's true of derivatives, right? This is if you're adding the two functions together or subtracting them and you're trying to integrate them, you could integrate each of them separately and then add them back together or subtract them. However, if you're multiplying two functions together in an integral, you cannot integrate them separately and just multiply their answers together. This is not true, and I want to emphasize that right there. Okay. So one other thing that's maybe a kind of a unique operation, because we know I think if you remember from pre-cal 1, when you have a even function, which means it's symmetrical about the x-axis, if you're integrating an even function from negative a to a, so the integral from negative a to a of f of x dx, that's going to be equal to twice the integral from 0 to a of f of x dx, if that makes sense. And again, the picture kind of illustrates it, because if this is an even function, which means it's symmetrical about the y-axis, that means that this right here is going to be the same area as that. So I could just integrate from 0 to a and double it. Okay? And the same thing if I'm looking at an odd function. Like maybe x cubed, and I'm integrating from negative a to a. So what happens is, you remember integrals are find the area of the curve, right? So if you look at that, what we realize is if you don't do anything with this to make an adjustment, if you think about these little rectangles that picture the Riemann sum for a minute. If I'm just doing, if I'm using f as my height of the rectangle, it's going to be positive here, but it's going to be negative there, right? So if I just run an integral from negative a to a of this function of x dx, well, it's going to count this area positive and that area negative. So this is going to end up just being 0, because this is symmetrical, because it is an odd function. It has point symmetry about the origin. That means that this shape here is exactly the same as that shape there, which means this area would be the same as that area. So those are two kind of just little unique things about even or odd functions. So that's some basic rules. Now let's talk about really what a derivative is. I mentioned that it's an integral. I mentioned that it's an antiderivative, which just means I'm undoing derivatives. And remember, I at the beginning of this class, I told you really need to be practicing your derivatives, because the better you can do your derivatives, the better you'll be able to undo them, which is what we're about to start doing. So for example here, if I'm trying to integrate sine x dx, actually let's forget about the integral for a while, we're just going to say antiderivative. So if I just want to know what is the antiderivative of sine x, well, the antiderivative is, I'm basically saying, what did I take the derivative of to get that? So we know that sine has to come from cosine, right? So I would say cosine x. So cosine x is the antiderivative. Now, just to make sure, I'm going to take the derivative of cosine and make sure I get that. So when I go to take the derivative of cosine, I realize that I actually get a negative sine x. So that means I need to adjust my original guess. So I'm going to say, well, maybe this should be a negative cosine. Now when I take the derivative of negative cosine x is negative sine x, which would be positive sine x. Okay? So same thing here. I'm looking at this. What's the antiderivative? So where did this come from? What function can I take the derivative of and get x squared? Well, I know that that's got to be x cubed, because when you take the derivative of x cubed, the power drops 1, right? The problem is when I take the derivative of x cubed is 3x squared, which is almost that, but not quite. It has an extra 3 out here. So what I'm going to do here is put a little 1/3 out front. So now when I take the derivative, 3 times 1/3 is 1, drop the power 1, and I get my x squared. Okay, so you can see how knowing your derivatives really well can be really helpful here. So let's do another one. What's the antiderivative of, let's say, 1 over x. Well, where does 1 over x come from? When we think about the power rule, that must have come from x to 0. No, that doesn't work. So we think a little bit harder and we realize, oh, wait a minute, the derivative of ln x is 1 over x. So this just must be ln x. And the derivative of ln x is 1 over x, so sure enough it worked. What if I had 1 over x plus 1? Well, once again, the derivative of 1 over x, I'm sorry, the derivative of ln of something is just 1 over the something, so maybe this is the natural log of x plus 1. Well, if the derivative of natural log of x plus 1 would be 1 over x plus 1 times the derivative of x plus 1 because of the chain rule, but there is no, the derivative of x plus 1 is just 1, so that would work. Now, what if there would have been a 2 here? And that means there would have been a 2 here. Now when we take the derivative of this, we get 1 over 2x plus 1, but then the chain rule kicks out a 2 because the derivative of 2x plus 1 is 2. So if we didn't do anything there'd be a little 2 sitting up here. So what we're going to do is put a little 1/2 out here to counteract the 2 that's being kicked out. Let me do one more. What if I want to do the antiderivative of 3x squared plus 5x minus 7? So where did that come from? Well, the 3x squared had to come from x cubed. So let's take the derivative real quick and say derivative of this would be 3x squared, which is exactly right, so I don't need to make adjustment. Where did 5x come from? Well, it had to come from x squared for sure. But if I take the derivative of x squared, that'd be 2x. And I want 5x. So that means I need to put a 5 here and put a 2 underneath. That way when I multiply by 2, those cancel out. I'm left with just a 5x. And finally, where did 7 come from? That had to come from 7x. Okay. So let's back up a minute here. Now if we're integrating, the only difference here is we put a little integral out front. We put a dx there, an integral dx. An integral dx, an integral dx, and an integral dx. And all of these are what we would call indefinite integrals because they don't have any indices on the integral. So when we're taking an indefinite integral, that means that I'm looking for all the functions that I could take the derivative of and get this. Now the problem is, if there is a little plus 1 here, the derivative of that would also be sine x, wouldn't it? Because the derivative of negative cosine x would be negative sine x, and the derivative of 1 is 0. So adding a constant out here doesn't change the result of the derivative. So anytime you're taking it, and that's always going to be true, right? I can add a constant to any one of these, and it wouldn't change the derivative. So that means anytime you're taking an indefinite integral, which means you don't have any limits on your integration, those little a's and b's from the fundamental theorem of calculus part 2. So when I integrate something without limits of integration, I always have to include a little plus c. Plus c, plus c, plus c, and plus c. Okay, so I encourage you to go and practice this. You're gonna, it's if you know your derivatives, basic derivatives really well, this shouldn't be too bad. But it still is going to be a little bit of a learning curve because you got to get used to going backwards. So practice, 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 practice.